is your YouTube video tutorial for Physics Topic 1 Motion. Now this appears in Physics Paper 1. Today this is going to talk you through scalars and vectors, speed, distance time graphs, velocity time graphs and acceleration. Please watch this video as many times as possible before your study club. So, to start us off, we're going to look at the definitions of scalars and vectors. A scalar quantity is something that has a size or magnitude but no direction. A vector has a size or a magnitude and a direction. So, some examples of some scalar quantities are speed, mass, and distance. And then their corresponding vector quantities are velocity, which is speed with a direction, weight, which is your mass multiplied by gravity, so it has a direction of moving downwards, and the vector quantity equivalent of distance is displacement. So the difference between speed and velocity, both of these runners are running at 5 meters per second, that's their speed, but the female runner is running in this direction. We'll give her a velocity of +5 meters per second. The male runner is still running at the same speed, but in the opposite direction. So we'll give him a velocity of -5, my pen's gone wrong, meters per second. And that's his velocity. Right, the next thing we're going to move on to is the equation linking speed, distance and time. So, distance equals speed multiplied by time. Now to use this equation you need to have the same units. So distance we want in meters, speed we want in meters per second, and time in seconds. You can put this into your formula triangle. Distance goes at the top, and this T for times means we do speed times by time. So there are two other equations we can pull out. Speed, if we cover it up, equals distance divided by time. And if we wanted to calculate time, time equals distance divided by speed. Whatever is on the top stays on the top, so distance is always on the top of the equation. If we wanted to do a calculation, for example, calculate the average speed of a motorbike that travels 120 metres in 8 seconds. So we're going to go back to our triangle, and the speed is what I'm calculating, so I need to find speed. I'm going to do distance divided by time, so I'm going to do 120 divided by 8 equals 15. Never give an answer without a unit. So it's 15, I calculated the speed, and the speed is going to be in meters per second. Okay, moving on to distance time graphs then. So, on a distance time graph we have time along the x-axis and distance up the y-axis. On this graph here, we've got a constant speed because it's a straight line. On this graph here, it's a curved line. which means it's accelerating. The speed is increasing. This line here, it's curving but in the opposite direction. So this one is decelerating. In other words, it's slowing down. And this line is flat, which on a distance time graph means it's stationary. In other words, it's not moving. So you need to be able to interpret a distance time graph as a whole. So here, this part of the line, it's at a constant speed because it's a straight line. The line then goes flat, which we know from before means it's stationary. And then it's at a new constant speed, but this time the gradient is much steeper, so we know it's at a faster constant speed. So we can describe that. You also need to know how to calculate speed from a distance time graph. So to calculate speed, we need to calculate the gradient of the line. If I wanted to calculate the gradient of this line here, I need to do the change in y divided by the change in x, or in other words, how much the line has risen divided by how much the line has run across, so the rise divided by the run. In this case, calculate the speed for each part of the journey shown in the graph on the left. If I want to calculate this part A, the rise is 0 to 80. So my rise is 80, and my run from here to here is 60. 80 divided by 60 equals I'm just going to call it 1.3. Now that's a change in speed, so my unit, as if before, is meters per second. Now if I wanted to calculate the gradient here, the rise is 0, and I know it's stationary. So B, I don't really need to do a calculation, but if I did, my rise is 0, my run is 60 to 120 is 60. 0 divided by anything is going to be 0. And if I wanted to do part C, my rise is from 80 up to 240. This is where a lot of people make a mistake. It's not 240. It's 240 minus 80. It's the difference. So the rise here is 160 divided by my run, which is 140 minus 120 is 20. 160 divided by 20 equals 8. So you can clearly see that this line shows a faster speed than this line here. There's another sum that we can do, is to calculate the average speed for the entire journey. Now the average speed is calculated by the distance divided by the time. So we're just going to do our speed equals distance divided by time, the total distance and the total time. So the total distance was 240 metres, and the total time it took was 140 seconds. Seconds, not metres. .71. Again, I need a unit, it's a speed, so it's metres per second. On average, the whatever it was, vehicle moved at 1.71 metres per second. Okay, I think we are now going on to velocity time graphs. So it's a similar setup, except this time on your graph you've got time along the x-axis and we've got velocity up the y-axis. on this first graph here, the velocity is remaining constant. So the line is flat, but it's moving at a constant speed. On this graph, the velocity is increasing at a constant rate. So this is accelerating, a constant acceleration. And this time it's sloping downwards, which means my speed is decreasing at a constant rate. So it's decelerating or slowing down. So if we apply those to this example of velocity time graph, here, when the line is at 0 on the y-axis, the speed is 0. So that means this part is stationary. We've now got a straight line sloping upwards. So now it's accelerating. The flat line is a constant speed. It's a constant speed of 20 meters per second. Here, we've got it decelerating, accelerating again. But this time the gradient is much steeper, so the acceleration is much faster. And again here we've got a new constant speed of 40 meters per second. There are two calculations that you have to be able to do with a velocity time graph. The first one is how to calculate the distance travelled. So you calculate distance travelled by calculating the area under the graph. For example, if we wanted to calculate distance travelled in the first 50 seconds, we'd go to our graph and we've got the first 50 seconds up to here. Now this shape here is called a trapezium, I believe. I don't know how to calculate the area of that shape, but I do know how to calculate the area of a triangle and a square. So what I can do for the area of the triangle is do half times by the base times by the height. This is the base, that's the height. So in this triangle here, I would have to do, I'm going to call this shape number 1. For shape number 1, I do a half, or 0.5, times by the base, which is from 10 to 30, so the difference is 20, so the base is 20, and times that by the height, which goes from 0 to 20, so you use the values from your axes, so 0 to 20 is 20. Plug that into our calculator. 0.5 times 20 times 20 gives us 200. So in the first sort of 30 seconds, it didn't move here, it travelled 200 metres. Then I've got to calculate the area of shape number 2. Now shape number 2 is a square, which is easy. We just do the length times by the width to calculate the area. So that side times by that side. So the length is 30 to 50. The difference is 20. The height again is 20. 20 times 20 equals 400. So it moved 200 metres to here and then 400 metres after that. So the total distance equals 200 from this part plus 400 equals 600 metres is the total distance travelled. One other sum that you have to be able to do is to calculate this acceleration. The acceleration is given by the gradient of that line. This is a slower acceleration than this one. So if I wanted to calculate the acceleration, let's call this calculation number 3. Again, gradient equals the rise over the run. The rise of the line is from 0 up to 20, so the rise is 20. The run across is from 10 to 30, so that's also 20. Plug it into our calculator. 1. Now acceleration is measured in meters per second squared. And we're going to move on to that in a second. There's another way to calculate acceleration. This is using a graph. You also have to know how to calculate it just using numbers and the following formula. So, acceleration is calculated by a change in speed divided by the time. Now you can write that as A equals V minus U divided by T, where V is the final speed and U is the start or initial speed. So, if we had this question here, for example, a cat changes its speed from 2.5 meters per second, that's its start, that's U, to 10 meters per second, that's its final speed, that's V, over a period of 3 seconds, that's our time. Calculate the acceleration. So, A equals V, which is 10, minus the U, which is 2.5, all divided by 3 seconds. 10 minus 2.5 is 7.5, and I always write out every single step, so I'm left with 7.5 over 3, which equals 2.5 meters per second squared. There is another formula to calculate acceleration. Now, if they ask you to use this formula, they will give you the formula in the question. You're not expected to remember this one. So, this is V squared minus U squared equals 2 times by A times by X. X is the distance travelled by whatever's accelerating. A is the acceleration, V squared is the final speed squared, and U squared is the start speed squared. So, you can plug this into a formula. Now, calculate the final velocity of the motorcycle. We're going to put this in a box and we're going to leave it together at the moment. So, V squared minus U squared equals 2 times by, this is the acceleration, 2.4 meters per second squared. And the distance it travelled was 200 meters. Because a motorcyclist passes through a green traffic light with an initial velocity of 4 and then accelerates at this, covering a total distance of 200 meters. So I can calculate this part. So V squared minus U squared equals 2 times 2.4 times 200 equals 960. I know what the initial or start velocity was, so I know what U is. So I can do V squared minus U was 4, 4 squared equals 960. Now what I can do is I can add 4 squared to both sides, or just take this 4 squared and bring it across the equals, and I can add it. So I'm left with v squared equals 960 plus 4 squared. I leave the 4 squared in brackets because I want it squared first. So v squared equals 960 plus bracket 4 squared, close brackets, 976. Then I don't want the answer squared, so I need to do v equals the square root of 976. Square root 976 equals 31.24 is my answer. It's v, which is final speed. Speed is meters per second, so always add your units. You will find extra information on pages 167 to 170 in your Combined Science Higher Revision Guide. Thank you for watching.